Hi everyone, this is Dr. Marks, and our topic for today is marginal analysis. We're looking at part 2, so the second half of this unit. Now, if you recall, we've said that in economics, people make decisions at the margin. So let's recall what we mean by the margin. By margin, we're talking about the difference between the status quo, so what we have right now, and some incremental change. So I've given examples like maybe the university wants to increase tuition from what it is now by increasing it by 2%. And maybe they want to look at 3% and 4%. Those are incremental changes, and of course they want to evaluate the potential costs and benefits of doing that. So in part 1, we introduced this idea of marginal analysis, how we think about things when we look at the margins. We used the rule of optimality, and the rule of optimality is incredibly important. You've heard me say that we're going to see the rule of optimality over and over and over again, couched in different ways. The rule of optimality says that it's rational to undertake something as long as marginal benefits are greater than or equal to marginal cost. So remember, we need to look at marginal benefits, compare them to marginal costs. It wouldn't make any sense for us to spend $3 on something that gives us only $2 of marginal benefit. So that, of course, would be irrational. But notice here the equal sign. Is it rational if marginal benefits are exactly equal to marginal cost? Of course it is. It's irrational, however, if marginal benefits are less than marginal cost. So at this point, you're familiar with this rule of optimality. We also learned how to calculate consumer surplus. So remember what we mean by consumer surplus. It's the difference between what I'm willing to pay and what I'm asked to pay. So I've given you examples like you go into Walmart, you want a pair of Levi's, you're willing to pay $30. That's kind of what's in your budget. And you get there, they're having a sale, and Levi's are $21. And so you're like, woohoo, Levi's are only $21. I was willing to spend $30. So you've saved, in a sense, $9. That psychic savings, money you were willing to spend but didn't have to spend, that's your consumer surplus. The previous examples that we looked at in part 1 of this topic were the easiest that you're going to see. And why were they easy? It's because I gave you marginal benefit and I gave you marginal cost. You didn't have to calculate anything. All you had to do is compare them using the rule of optimality. So I need to tell you that you're not going to have marginal benefit and marginal cost on all your homework and quizzes and tests from now on. I'm going to make it a little bit harder where you have to calculate something. Therefore, we need to know how to calculate marginal benefit and marginal cost from information that we're given. And that's what we're going to focus on this lecture, okay? How do we calculate marginal benefit? How do we calculate marginal cost? So let's go back to our shoplifting example. What if we had total benefits instead of marginal benefits? So instead of marginal, I give you total. And what if I gave you total cost instead of marginal costs? Well, you have to read questions carefully and see what I've given you. You would have to find marginal benefit and marginal cost before you could actually solve the problem, right? So that's what we need to do today. Now remember the rule of optimality. I'm going to beat this to death because people just forget this. It says that it's rational to undertake an activity if marginal benefits are greater than marginal costs. Well, if you don't know marginal benefits and marginal costs, you can't apply the rule of optimality. It doesn't apply to total benefits and total costs because that's not thinking marginally. So let's start with total benefits, and I'm going to give you, and we need to calculate marginal benefits. You're going to see how easy this is. So what if I tell you that one security guard creates $700 in total benefits? Now remember, we're hiring security guards and they're decreasing theft and shoplifting. So the benefits are measured as the shoplifting we save, that we eliminate. So one security guard eliminates $700 of theft. Now on the next line, two security guards together eliminate $1,325 in theft. But 3 security guards together, $1,825, and 4 security guards together, 21.25. Do you see where we're going with this? I keep saying the word together. So total benefits means added together. Guard 2, Guard 3, Guard 4 added together gives us $2,125 worth of total benefits. But as I said, we need marginal benefits. So what we have to do is calculate them. Now, let's make sure you understand the difference between marginal benefits and total benefits, just intuitively. Now, remember that marginal benefits looks incrementally at the margin. We're talking about incremental changes. So marginal benefits, we're looking incrementally. We're looking 1 unit at a time. So in this case, we would be asking about the marginal benefit of just the first guard and the marginal benefit of just the second guard and the marginal benefit of just the third guard. So incrementally, just the first, just the second, just the third. Well, that's different than looking at total benefits. Total benefits looks at, as the name suggests, the total, right? We're looking at things together. So looking at units together, I need to look at the impact of guards working together. Oops, sorry. So what is the total benefit of 2 guards together? The total benefits of 3 guards together. So marginal looks at incremental changes, total benefits, adding them together. So we have a very simple equation that explains where total benefits comes from. We take the sum of the individual marginal benefits, and that gives us total benefits. So the sum of the marginal benefits gives us total benefits. So marginal benefit of the first guard, if we go back to our first lecture, was 700. The marginal benefit of the second guard was 625. Well, that's where we got the total benefit for 2 guards of 1,325. So is everybody with me? You added the marginal benefit of the first guard to the marginal benefit of the second guard, and that's where total benefits comes from. So bottom line, how do I get total benefits? I sum together the marginal benefits. But how do we go from total to marginal? Well, we just did the opposite. The sum of the marginals equals the total. But what if I want to go from total back to marginal? I have to use this equation. Marginal benefits are the change in total benefits given a change in Q. So change in total benefits given a change in Q. Well, what's Q? Here we're talking about quantity. So in this case, it's quantity of security guards. Sometimes it helps to read this as an equation. What is the numerator? Change in total benefits when I create a change in Q. One thing I want to point out is that the symbol in math for change in is the delta, right? The triangle. So I could have put delta total benefits over delta Q, and you will see that in lecture. So please make a note of that. So a simple example. If 2 guards together save $1,325 and 1 guard saves only $700, I need to ask, what's the change in total benefits when I change from 1 to 2 guards? Well, what's my change in Q, everybody? I changed by how many guards? 1, right? I went from 1 to 2. So the denominator is 1. What's the change in total benefits? Well, it went from 700 to 1325, so it's 625, right? The second guard must have a marginal benefit of 625. So very simple stuff, right? We've just calculated marginal benefit. Now, I want to point out something very important when you're doing marginal analysis, and that is that there's an implied 0 guards. Our initial margin, our initial status quo is that we have no security guards, but we're thinking about hiring some. So it's important to understand that there's an implied 0 guard. That's our status quo when we're thinking about hiring the first guard. So going from 0 to 1 is our first margin. But that 0 may not always be there. I'm not going to, on a test, give you 0 guards, 0 benefits, okay? You're going to have to remember that there's that implied 0 guard. The other thing that you're going to have to note is that Marginal benefit is only defined when Q is changing, right? Think about the equation. It was change in total benefits over change in Q. But if we're just sitting there at 0, we have no security guards, nothing is changing. So there's no marginal concept. So I'm using a dash to suggest that it's mathematically undefined until guards start changing. All right, so let's take a look here. Here's our equation. Marginal benefit is the change in total benefits that come from a change in Q. So our first margin is 0 to 1. That's why you have to remember about that implied 0th security guard. Well, when we go from 0 to 1, do you agree we have a change in 1 security guard? So our denominator is going to be 1. Our numerator is the change in total benefits. Well, it went from 0 to 700. So does everyone agree it's a change of 700? So if I wanted to calculate marginal benefits, it's very simple. 700 divided by 1. There we go. Now, somebody might be thinking, what if I went from 0 to 5, 5 to 10? Well, that is possible. Maybe we're not going to hire them individually. We'll go from 0 to 5 guards and then 5 to 10. Change in Q in that case would be 5. So just make sure you're calculating the denominator correctly. In this case, it's 1, but it doesn't have to be. All right, our next margin is 1 to 2. We've already gone from 0 to 1. Now 1 to 2 guards. So again, change in quantity is 1. Our total benefits go from 700 to 1325, or 625, right? Total benefits increased by 625. So the marginal benefit of hiring the second guard, not 2 together, but the second guard, is 625. So take a second and make sure that you can complete this entire table and find the correct marginal benefits. So I'm going to wait just a second while you do that. You might want to pause really quickly until you get your work completed. All right, hopefully you see that the marginal benefit of the third guard is $500. The marginal benefit of the fourth guard is $300. The fifth guard is $220. The sixth guard, $125. And the seventh guard, $75. We do see diminishing marginal benefits here, right? For each additional guard, we're starting to have smaller and smaller benefits in terms of we're reducing theft by some amount, but it's getting smaller and smaller and smaller. The impact of additional guards is falling. Now let's look at marginal versus total cost. So we just did the benefit side. If you understand that, you're going to understand this. It's really the same thing. So marginal cost again looks incrementally, hence the term marginal. We're going to look one guard at a time. We're going to ask, what is the marginal cost of hiring just the first guard? What is the marginal cost of hiring just a second guard? And the marginal cost of hiring the third guard. So we're looking incrementally. Instead, if we look at total cost, we're looking at the total together. So what is the cost of 2 guards together? What is the cost of 3 guards together? So marginal looks incrementally, first, second, third. Total cost looks at the total together, 2 together, 3 together. We have a similar equation. If we want to find total cost, what we need to do is add up the marginal costs. So the sum of the marginal costs equals total cost. Well, if the marginal cost of the first guard is $100 and the marginal cost of the second guard is $100, because remember our example, we're using the same example, we can get as many guards as we want for $100 a day. So add these up and you see that the total cost of 2 guards is simply $200, right? So summing up the marginal cost gives us total cost. But now we want to go the opposite direction. So how do we go from total to marginal? Well, marginal cost is defined in the same way as marginal benefit. In this case, it's the change in total cost over the change in Q. So how does total cost change when we change Q? Q again is the same thing, quantity. So do you agree that it's the same exact equation as marginal benefit, but instead of total benefits, we're looking at total costs? Otherwise, it's the same equation. Also remember, change in, we use the triangle delta, so I might put delta total cost divided by delta Q. So if 2 guards cost $200 together and 1 guard costs $100, then the second guard must cost $100. Everyone agree with that? The second guard must cost $100. And that's marginal cost. Very simple. Again, don't forget about that implied 0th guard. I'm not going to give that to you on tests, but you've got to remember it's there. And also remember that marginal cost is only defined when Q is changing. So sitting at 0 guards, nothing is changing, so it's mathematically undefined. And that's why I have the dash there. So once guards start changing 0 to 1, 1 to 2, then marginal cost is mathematically meaningful. So let's use the equation, and we see that going from 0 to 1, we hire 1 guard. Our total cost goes from 0 to 100. That's a change of $100. So what did it cost us to get 1 additional guard? It cost us $100. Now our next margin is 1 to 2. When we go from 1 to 2, how many more guards are we hiring? Remember, we got to look at the change in. So it's not 2 guards, we're hiring 1 more guard. So the change in Q is only 1. Total cost goes from 100 to 200. So it's a change of 100, which means the marginal cost of getting a second guard is $100. You guys get the idea. So let's put the whole example together. Well, we've already calculated marginal benefits. Now take a second and calculate marginal cost. It should be pretty obvious. So take a moment and fill out marginal cost and make sure you understand how to calculate those numbers. And do you agree that marginal cost in this example is constant, right? Each additional guard will cost $100. So now we have everything that we need to apply the rule of optimality, right? We have marginal benefit and marginal cost. Folks, at this point, is total benefit relevant for using the rule of optimality? No. Is total cost relevant when we use the rule of optimality? No. Marginal benefit and marginal cost only. So let's look at how many guards to hire. Does everyone agree we'd hire the first guard? Marginal benefits are 700, but marginal cost is only 100. You should be able to calculate consumer surplus along the way, right? So the consumer surplus on just that first guard is 600. Do you agree? What about the second guard? Does it make sense to hire him? Sure it does. Our marginal benefits are 625 and it only cost us $100. So guys, what's the consumer surplus here? It's going to be 525, right? We're willing to pay up to 625. We only have to pay 100. Should we hire the third guard? Yes, for the same reason. Our marginal benefits are 500. Marginal cost is 100. So you should see that we have consumer surplus of $400. It's definitely rational to hire that guard. What about the fourth guard? Well, it's rational to hire him too. Everyone agree consumer surplus is $200. What about the fifth guard? Yep, rational to hire that guard too. Consumer surplus here is 120. The sixth guard is also rational. Although, do you agree, our consumer surplus is starting to shrink. We only have $25 of consumer surplus here. What about the seventh guard? Is it rational to hire the seventh guard? Well, the answer is no. Now, some people get confused here. They look at total benefit and they're like, oh, the total benefit's greater than total cost. Is that relevant, guys? No. marginal benefit is $75. The seventh guard reduces theft by $75, and it costs $100 to make that guy, work for us. We're losing $25 on this deal. Consumer surplus is negative. We definitely wouldn't hire him. So it's rational to hire 6 guards, but it's not rational to hire 7. Okay, so 6 guards. Let's work another problem from start to finish. And again, I'm going to give you total benefit and total cost. You're going to apply the rule of optimality, but remember, you've got to find marginal benefit and marginal cost. That's what is required for the rule of optimality. That's for efficient decision making. All right, so take a second and calculate marginal benefit and marginal cost. All right, let's check our work. Remember, total benefits is our total willingness to pay for ice cream here. So we're trying to decide what's the optimal number of scoops of ice cream to eat. And total cost is what you're being asked to pay. So check your work. Make sure everything is correct. Hopefully, you're not having any problems. I want to point out that we have negative marginal benefit for 5 scoops. Everyone see that? So I'm actually worse off if I eat a 5th scoop, right? That's like having 1 too many slices of pizza and you now feel like you're going to puke, or people who drink 1 too many beers and now all of a sudden they start feeling sick. So understand, if we get confused and we simply compare total benefit and total cost, does everyone agree that we would eat the 4th scoop and the 5th scoop? But that makes no sense, right? In this case, marginal benefit's becoming negative and it's 0 for 4 scoops. Guys, how many scoops of ice cream are we going to eat here? We're going to eat 3 scoops, right? So let's make sure you're with me. It's rational to consume the 1st scoop, the 2nd scoop, and the 3rd scoop. But we would stop at the 3rd scoop. It's not rational to consume the 4th or the 5th. All right. So as we said, we consume the first 3. We would not consume after that. Sorry, let me go back for a second. We would not consume any further. So 3 scoops, and then we have negative consumer surplus. Okay. Now in this example, we're looking at putting in street lights, and each street light's going to cost us $700. Same thing. I want you to use total benefit and total cost to make sure you can find marginal benefit and marginal cost. So again, I'm going to pause so that you can complete this problem. All right, let's make sure we're getting marginal benefit right. Remember the implied 0 streetlight. The first margin is 0 to 1. Does everyone agree that the value of just the first streetlight is $1,300? Going from no streetlights to 1 streetlight, the benefit changes by $1,300. But going from 1 to 2 streetlights, for the 2nd streetlight, it goes up by $1,100. For the 3rd streetlight, it goes up by $900, then $800, then $600. Same thing with total cost. We've got to calculate marginal cost. Does everyone agree that our marginal cost here is constant at $700? So the first streetlight costs $700, but 2 together is $1,400, and 3 together is $2,100, and 4 together is $2,800. So each time the marginal cost is $700. So now we need to decide what's the optimal number of streetlights. Should we have the first streetlight installed? Yes, look at that. The marginal benefit is $1,300 and the marginal cost is $700. And 2 streetlights, $1,100 and $700. Third streetlight, our marginal benefit is $900. Our marginal cost is $700. So that's also rational. Fourth streetlights. The fourth one makes sense as well, right? The fourth one has a marginal benefit of $800 and a marginal cost of $700. So it makes sense to install the first, the second, the third, the fourth. But guys, what about the fifth? Is it rational to install the fifth streetlight? No, the fifth streetlight we wouldn't want to install because the value is $600, but the cost of doing so is going to be $700. We actually have negative consumer surplus of $100, right? So, marginal analysis, guys, pretty simple. Hopefully you understand very clearly that you've got to calculate marginal benefit and marginal costs. Okay? All right. Now, what I want to think about next is if we created a graph to illustrate this example, what would it look like? So let's do the streetlight example. Now, I'm not asking you to literally plot because that will take too long, but if I want you to estimate what the marginal benefit curve looks like and the marginal cost curve looks like, what would they look like? So I'm going to pause for a second and you kind of sketch it out, and it doesn't have to be exact. Everyone agree that we have a downward sloping marginal benefit curve. Now, I agree that if I literally plot the data that I gave you, it's not actually going to be a straight line. We have a little bit of lumpiness, right? It's a little jagged, but generally it's a downward sloping marginal benefit. But what's marginal cost going to be like? It's 700, 700, 700, 700. So do we agree? Oh, sorry. I need to go back and answer this question first. My bad. Go back to the green note that just popped up. Could marginal benefit become negative? What would that imply? So is it possible that that marginal benefit curve really extends to where it gets negative? What would negative marginal benefit mean? Is it possible for an area to be too bright? The answer is probably yes. If you've got streetlights all over your street and you just can't get it dark enough to go to sleep, it's annoying, it's so bright, it hurts your eyes, that would probably be negative marginal benefit. So could we end up with negative marginal benefits for streetlights if it starts hurting our eyes or just makes it too bright at night and we can't sleep? Yeah, I think we could. So I'm sorry, I was asking the question now about marginal cost. What's marginal cost going to look like? Well, if marginal cost is constant at $700, then it's going to be a horizontal line. So we have a downward sloping marginal benefit curve and we have a horizontal marginal cost curve, right? Now, we figure out that these intersect somewhere between the fourth and the fifth streetlight, right? And if we had thousands and thousands of units, we'd probably end up right at the intersection. But we've got a lumpiness thing because there's only 5 streetlights. So we're actually going to end up purchasing only 4 streetlights because we agree it would be irrational to buy and install the 5th streetlights. The marginal cost is greater than the marginal benefit, and that makes us worse off. So let's quickly recap. Decision makers think marginally. And so to make ourselves better off and make sure that we allocate resources efficiently, we follow the rule of optimization, which means we think about marginal benefits, which means is also called our marginal willingness to pay. Now, if you don't have that in your notes, guys, you need to get it in your notes. Marginal benefits and marginal willingness to pay mean the same thing. We have to think about marginal costs as well. So marginal benefits and marginal costs. When we think about it this way, guys, it's going to result in the best allocation of resources. We're going to make sure that resources are used where they're most highly valued. It's going to maximize our consumer surplus, and it's going to maximize our net benefits. And this is important for economic decision making. Much of what we do in Econ 217 is some version of marginal cost, marginal benefit. So folks, if you get this down and you really understand it, it's going to make a lot of things we do this semester far easier because there will be lots of examples of marginal analysis, but we might call it slightly different names. If you have any questions, please let me know. Thank you so much for listening and have a great day.